Hi everybody. Today we are talking about factors and multiples. So this is lesson 5 in your workbook, page 295. So make sure you are following along and completing the activities with me. All right, I'm going to switch you around and let's get started. So like I said, we're talking about greatest common factors and least common multiples. And this is something we've already touched on a little bit this year, but we'll dive deeper into it right now. So a common factor is a number that is a factor of two or more numbers. So factors, remember, those are the numbers that we multiply together. So for example, if we were going to find 10, right, you might use 2 and 5. 2 and 5 are both factors that we would multiply together to get to 10. So the greatest common factors of two or more numbers is called the greatest common factor. So say I wanted to find factors, the greatest common factor of 10 and 5. Well, 2 times 5 is 10, and I know I can do 1 times 5 to get 5. So the greatest common factor here would then be a 5. You can find the GCF of two or more numbers using different methods. Some of these methods include listing the factors or making a factor tree. So we've done a couple of these, and you actually have a table of factors that you can use at any time. So that's when we list, okay? So if we were finding the factors of 9, 15, and 18, what we would do is we would list all the numbers that we would use to multiply to get to 9. So 1 times 9 or 3 times 3. Factors of 15, 1, 3, 5, 15. And factors of 18 are 1, 2, 3, 6, 9, and 18. My dogs are fighting over a bone. I'm sorry. So when we look at these, we want to find the biggest number that's shared between all three. Usually what I do is I go to my shortest list. It has the fewest numbers, and it has to be one of these three numbers that are shared between the three. So I'm going to look. 9 is here. Is 9 in this list? No, it's not. So already we know that 9 is not possible. How about 3? Here's 3. 3 in this list? Yes. Is 3 in this list? Yes. So we would know that the greatest common factor here would be a 3. Okay. So let's take a look at example 1. We're going to use our list of factors to find the greatest common factor of 12 and 28. The first step is to list all of our factors of each number. 12, 1, 2, 3, 4, 6, and 12. Factors of 28, 1, 2, 4, 7, 14, 28. Then identify common factors. 1 is shared, 2 is shared, 4 is shared. Anything else? Nope. Now, what's the largest one that's shared between all three? That would be 4. Okay. All right, on your check, we're going to list the factors of 9 and 20 and then find the greatest common factor. Now, I'm going to have you pause here and see if you can find it yourselves. So, when you do this, you list out your factors 1, 3, 9. 1, 2, 4, 5, 10, 20. And we see if anything is shared. Now remember, I said take the shorter list. Start there. Is 9 in any of this? No. Is 3 in any of this? No. Is 1? Yes. So 1 would be your greatest common factor. And it is possible that 1 might be the only common factor. Now the second way to do this is to use a factor tree. For greater numbers, what we would do is we would make what's called a factor tree. And notice that it has little branches off of it, and that's why we call it a tree. So how you do this is you start with the numbers, okay, 52 and 78, and we start dividing by 2. 52 divided by 2 would then be 26, okay. Then we would say, what if we divided this again, right? We would get 2 times 13. So you get all the way down to a prime number. So here's a prime number. Okay. So let's take a look here. 78 divided by 2. 70. divided by 2 is 35. 8 divided by 2 is 4. So this would be 39. Okay, so then we would say how many times 39 would we get? That would be a 3. Okay, so now we have these prime numbers. All of these are primes. 2 times 2 times 13 would equal 52. 2 times 3 times 13 would equal 78. We get all the way down to the prime number. Now, because 2 and 13 are factors of both 52 and 78, the product of 2 and 13 is also a factor of both numbers. So we multiply the common prime factors to find the GCF. So when we looked at these, what was common? A 2 was common and a 13 was common. These two are not common, so we don't use those. We would just simply use the 2 and the 13. So then we would do 2 times 13 to get 26. So the greatest common factor here would be 26. Now we're going to do the same thing with 45 and 75. So you're going to try using a factor tree to find this. So remember, the first thing that we would do is divide this into its pieces, all the way down to its prime numbers. So I know here that 3 times 15 is equal to 45. Okay, I'm going to bring 3 down again, and I'm going to break up the 15 into 3 and 5. So now these are all prime numbers. That's as small as I can go. For this one, I'm going to do 3 and 25. Bring 3 down because it's already prime. And I do 5 and 5, that's 25. Now we look what's common. The 3 is common and a 5 is common. These two middle numbers are not common, so we're not going to use those. We simply do 3 times 5. So our GCF is 3 times 5, or 15. There we go. So that's how we find using a factor tree. You get it all the way down to its prime number. All right, so let's talk about common multiples. The least non-zero number that is a multiple of 2 or more whole numbers is called a least common multiple. And remember, when we're talking about multiples, so if I said multiples of 2, that's all the numbers you would say when counting by 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, so on and so forth. Okay? So multiples are the numbers that increase, right? We multiply to get bigger. Okay? So you're counting by that number. There's 2 different ways to do this. One is listing the multiples, like that, or using a number line. You could create a number line to show this. Now, if we are listing the numbers here, we're going to just list the first 6 non-zero multiples of each number. Multiples of 4, here we go. Multiples of 6, there we go. So the common multiples in this list would be 12 and 24. Now, because we're finding the least common multiple in this case would be 12. Now, the other way to do this is to use a number line. We're going to put the multiples of 4 as x's, 4, 8, 12, 16, 20, 24, and the multiples of 6 as a dot, 6, 12, 18, 24. Now, wherever we see both an x and a dot would be a common multiple. So the least common multiple, the furthest to the left, would then be 12. So 2 different ways to find the same thing. So let's take a look at example 1. Ernesto is at the community center every 8 weeks for his painting class. Kamala is at the community center every 6 weeks for her pottery class. They were both at the center for their classes this week. How many weeks will it be until they both have their classes in the same week again? So, one thing to do, start by listing the multiples. Multiples of 8. 8, 16, 24, 32, 40. 6. We would use 6, 12, 18, 24, and 30. Okay, so now we can figure out what's common. Well, 6 is not in both lists. 8 is not in both lists. 12, 18, 24. 24 is in both lists. So 24 would be our least common multiple. Okay? So Ernesto and Kamala have their classes in the same week again in 24 weeks. That's what we learned from that. Let's do our check. Once again, after we read the question, you can pause and solve on your own. Every 10th week, Tamika visits the zoo. Every 12th week, she visits the local pet rescue. If she visited both this week, how many weeks will it be until she visits both in the same week again? So once again, you're going to make a list of the multiples until you hit something that's in both lists. So I'm going to go ahead and go 10, 20, 30, whoops, there we go, 40, 50, 60, 70, 80. I'm going to do the same thing with 12s. 12, 24, 36, 48, 60, 72, 84. And then we look what is common. Well, going through my list, the least common multiple here would be 60. So the answer would be 60 weeks. Now, we can do the same thing using a number line, right? So if we're using a number line to find the least common multiple of 2 and 3, we're going to place an X above each multiple of 2, 2, 4, 6, 8, 10, and 12. And we're going to place a dot above each multiple of 3, 3, 6, 9, 12. What is the least number with both an X and a dot? In this case, it would be the 6. So our least common multiple of 2 and 3 is 6. Okay, go ahead and use your pause here to find the least common multiple of 2 and 8. 2, we're going to use as an X. 8, you can use as a dot. Go ahead and pause and find your answer here. All right, so you should have put X's over 2, 4, 6, 8, 10, and 12. 8, we would put a dot at 8. So what is the least common multiple? The LCM is 8. All right, last thing we're going to look at here is our apply question. So the table shows the supplies a school supply store has left at the end of the week. The store manager wants to put pencils and notepads together in bags to sell as a combo pack. And he wants to make the greatest number of bags possible. If all the pencils and notepads are distributed evenly among all of the bags, and the store charges $4 per bag, how much money will the store bring in if they sell all the bags? Now, we only need to worry about pencils and notepads. All of the rest of this is irrelevant information. So we have 48 and 36. What you need to do is figure out a way to divide up 48 and 36 into the greatest number of bags. Okay, so as always, what I would like you to do here is to give this a shot. Email me the answer when you've found the answer, and hopefully you can discover what it is. So, as always, if you have any questions, please let me know. I'm happy to help at any time. Make sure to complete your homework online. The assignment is on page 303, and I believe you're doing evens only. So let me know if you have any questions, and have a great day.